All right, today's lesson is 3.2. We're going to talk about solving systems by substitution. Remember, we talked about the three methods that we want to use to go ahead and solve systems are number one, graphing, which was lesson 3.1. Okay, so that was 3.1 that we just did. A second way to go ahead and do it was through substitution. That's what we're going to go ahead and we're going to teach you today. All right, that's section 3.2. All right, and then another way that we want to go ahead and we want to solve systems of equations is through something called elimination. Okay, now in class I went ahead and I talked with you guys about the appropriate times to go ahead and use each of these and what they're for. Okay, so I'm not going to go through that. I'm just going to kind of go through and show you how to do these today. All right, so for substitution, you take a look at this first equation right here. Okay, this first equation is in standard form. It is in the form of ax plus by is equal to c. The second equation, you have y equals. You have this variable right here isolated all by itself. Okay, this is a good time to use substitution because what you can do is you can take whatever y is. So you see that y is 2x plus 14. And you're going to substitute it in for that y right there. Okay? So now here's what happens. You have negative 3x minus 2. Now it's not y anymore. We know that y is equal to this. So I'm going to substitute in 2x plus 14. Okay? And it all equals 14. So all I did was I got rid of that y. Now we're going to distribute here and distribute here. So I'm going to be left with negative 3x minus 4x plus, excuse me, let me erase that. I screwed that up. Okay. This times this is going to give me minus 28 is equal to 14. Negative 3x minus 4x gives me negative 7x minus 28 equals 14. I'm going to add 28 to both sides to balance my equation. So I'm going to be left with negative 7x is equal to 42. When I divide by negative 7, divide by negative 7, I get x is equal to negative 6. Okay, now I want you to remember the solutions for these. It is going to be an ordered pair. It's an x comma y. So we found x, and what I'm going to do right now is I'm going to take and I'm going to put x right here, and that's going to help us to solve for y. So I got y is equal to 2 times negative 6 plus 14. So I substituted in for x now. And I get y equals negative 12 plus 14. So I get y is equal to 2. So my solution to this system's equations, negative 6 comma 2 is my ordered pair. And if we wanted to check it, we would substitute it into both equations up here. And we would go ahead and see if it is true for both of them. Okay? Let's go down here to number 3. All right, for number 3, again, standard form, and then you got y all by itself here. All right, what you're going to do is you're going to take this expression that y is equal to, and you're going to substitute it in for y. So when you rewrite this one now, it's going to say 18x minus 3, and now y is actually equal to this expression right here. So you got 6x plus 8 equals negative 5. Okay, again, distribute and distribute right here. So what do we end up with? 18x minus 18x minus 24 is equal to negative 5. Now, let's go ahead and let's combine some like terms right here. All right, 18x minus 18x is going to give you 0. So 0 minus 24 is equal to negative 5. So you end up with negative 24 is equal to negative 5 because your variables right here, all right, took you to 0. So, does negative 24 equal negative 5? Well, we know that that's not true. So here's what happens. Whenever you end up with something like this that's not true, you know that you're going to have a no solution for your systems of equation, which we know means that my lines are going to be parallel. They're never, ever, ever going to intersect. Okay? The slope in this one right here is equal to 6 over 1. Guess what this slope in this one right here is also going to equal? It's also equal to 6 over 1. Okay? Now, if this would have said -5 equals -5, then you know it's the exact same line, and it would be infinitely many solutions. Okay? All right, last example I'm going to do here with you guys for substitution, and we should be okay, is this one right here, number 4. Okay? This one is different because this is in standard form, and this is in standard form. So to use substitution, what we're going to have to do is we're going to have to decide, well, which equation would be easier to go ahead and isolate a variable for? And I'm thinking that this equation right here is going to be the easiest to isolate x by itself. So what I would do is I would subtract 4y, and I would subtract 4y, and I'd be left with x equals -4y minus 1. So now I have this equation, and I also have this equation right here. All right? What's different about this one is this time I have x by itself, but that's okay. All you do is you take what x is equal to, the expression, and you take and you put it right in there for x. All right? So really what we're looking at here is we're looking at -4, all right, minus 4y minus 1, and then you got minus 8y is equal to 4. Only variable, and here's my y variable. I'm going to take, I'm going to distribute, and I'm going to distribute. I'm going to be left with 16y plus 4 minus 8y is equal to 4. All right, combine like terms here. I end up with 8y plus 4 is equal to 4. I'm going to subtract 4, so I get 8y is equal to 0, and I'm going to divide by 8, so I get y is equal to 0 right here. Okay. Remember though, we want to go ahead and we want to do it as an ordered pair. So I'm going to take this 0, and I am going to put it into my y value here. So I'm going to be left with, I'm going to do it in red, x equals -4 times 0 minus 1. So I get x is equal to 0 minus 1. X is equal to -1. So my ordered pair for this one is -1 comma 0. That's substitution, guys. You take from one equation with an isolated variable and you substitute it into your standard form equation.